Hi, welcome back for another 5 Caillou challenge called Number of Trailing Zeros of n factorial. Write a program that will calculate the number of trailing zeros in a factorial of a given number. Remember that n factorial is calculated by multiplying all the digits from 1 up to n. So if n were 5, it would be 1 times 2 times 3 times 4 times 5. Warning, be careful. 1000 factorial has over 2500 digits. They've got a nice link here that we'll check out. They give you examples so you can see 6 factorial, how that breaks down. Get 720, and then they've got 12 here, and you can see how quickly this function explodes in terms of size. So this hint, you're not meant to calculate the factorial. Your input's going to be too big. Find another way to find the number of zeros, and they actually gave you the way. Just follow this link here. So let's go check that out. You'll notice this is what it looks like at the top, but if you scroll down a little bit, you've got this bit to calculate the number z of trailing zeros, exactly what we want for n factorial. Use this formula, and if you're unsure what this k-max term is up top, they define it for you. K-max is equivalent to the floor. That's what these kind of bracket looking symbols are for. The floor, that means just round down to the nearest integral value of the log base 5 of n. And so we're going to learn how to use, we've used math floor, but we'll learn that math class also has a log function to help us get logarithm. So yeah, basically the whole challenge then is how to translate this mathematical formula, these formulas, into C# code. So let's go ahead and do that. I'll go back. I'm going to do this in 2 steps. We'll first figure out this k-max thing. I'll call it k-max. And they told us that was the math floor. We've seen floor. And note, because I define this as an integral value, an integer, I'm just going to cast the result to an integer. And so they said, take the floor of the log base 5 of n. And actually, I'm going to rename this parameter to factorial. I like. Good. So, and we need the log base 5 of it. Let's double check that. See here, log base 5 of n, which is our input value. So math has this handy log, and you can consult your docs here. You see math log returns the logarithm of a specified number. They got 2 overloads. If you just are using the natural base, e, you don't have to provide the second parameter, but if you're working with a different base like we are, this is very handy. Well, in the second slot, we'll put the base that we want. See how the second parameter, it's a little ambiguous at first because they're both doubles, but you can see the second one is the base value, and the first one's the value that you want to calculate the logarithm of. So let's use that. We can say math log, factorials the number, and we want base 5. That closes the floor. And so at this point, we have our k max value. So let's go back. We have k max now. And so that was really the only uncertain term at first. I mean, we're solving for z. We don't know z yet, but we know we're going to do a summation. That's what this sigma symbol is here, this big E looking thing. It's saying go start at k equals 1 to k max, which could be 5, it could be 12, it could be, who knows, whatever number. But hopefully that reminds you of like a for loop, right? And then for each one of these k values, you know, 1, 2, 3, we're going to calculate the floor of the input, the factorial number, over 5 to the k power. So see if you can implement that. We can go, I'm going to make a local variable here to hold the sum as we accumulate, and then we can say int k. Normally we use I, right? I'm using k because that's right out of the formula. Why not, right? Help us speak straight, you know what I mean? We can easily see how this correlates to the formula. So k is less than or equal to, I'm sorry, me running on defaults again. It said from 1 to k max, right? So let's start at 1. Old habits die hard. And increment k each time through the loop. And so as we go through each value, right, we want to sort of add on to our running total. And it said math floor again. And I'm going to, math floor returns a double if you recall. So that's why I'm adding these casts to integer to our, so our final result comes in as an integral value. And then it said it was the factorial value over, what was it? 5 to the k. That's what it was. So we'll hit math. We've used math power before, but feel free to look at the docs if you don't remember. 5 to the k. And then the idea is once this loop has run through, you summed all those parts together, you can return your sum. And according to that math reference, that's the number of trailing zeros through math magic. So I'll go ahead and run this. I have the system namespace, which should be necessary for these math classes. Let's see if we got it. Cool, we hit the test, but we don't claim victory until we hit the attempt. Good, so you're clear to submit at this point if you want. The big key was doing that translation from math formula to computer code. I'm going to go through one more solution if you want to see how you could wrap this whole bit up here into a one-line link statement. So equivalently, you could say, kind of generate that range that we're going to loop over. If you want to pause the video and try and figure that out, that would be an extra good challenge you could do. I'm going to go from 1 to k max. And so, you know, you can imagine range is going to return a collection of integers 1, 2, 3, 4, all the way up to k max. And then I'll transform each of those values based on the formula, what it does for each step. And then at the end, right, we'll just call sum on it. We know that link provides this sum method. And that should be the equivalent of the for loop that we had before. So in select, right, select is selecting from this range. We're projecting it into a new sequence. We're transforming it. And so I'll use n for my element name for each element. And then we're just going to basically do the same calculation, the same formula. In fact, I should have just copied the last one, but that's fine. We'll do the floor of n over 5 to the k. So we can say, I want, actually, math floor of factorial over math pow 5 to the, you know what, yeah, let's keep it all straight. Again, a habit for integers I use n, but the formula said k. Let's just use k. Make everything jive, right? So I've got math floor. I'll convert it to integral values because that's what I want. So you see how it, for each k value, I'm making that calculation, and it's putting them all in a collection, and then finally saying sum. Hopefully you can see how this is the same as the for loop, assuming I didn't make any typos or anything here. We'll find out soon. Test passed. And all green. Cool. And so if you really want, to be that one-line Wally, you don't even need this temporary variable here. You could say, I'm going to take this, put it in for k max. You know, I hope you can see how this becomes much less readable. It gets ugly quick. So, but if you want to be a one-liner here, I think this should still work. So yeah, you're clear for submission. Maybe I'll do that for fun, not the nicest looking solution. One thing I would add too is that if you stumbled upon this code in a real life scenario, you know, at least me, I'm not going to immediately recognize what this formula is for. So I would definitely put a comment with the link, this Math World link here, saying where you got the formula from, and then people can read the description and figure out and understand, you know, what's going on there, because it's not immediately clear. Calculate number of trailing zeros. And so yeah, you put the link there. That's a helpful comment. I don't use comments a lot. I try to write clear code instead, but comments are definitely helpful from time to time. So I think that's a nice final touch. Up to you if you think the K-max one. You know what? I am going to go back to the K-max one. I'm going to save my comment though, and I'm going to go back. That's a lot more clear to me. I just like that better. And it's not a big deal to have 2 lines. I mean, get over it. Submit. I will run with that. And yeah, feel free to go through other people's solutions. Learn from everybody. Let's learn from each other. You know where to find me if you have questions, comments, or concerns. So hit me up. Otherwise, I'll see you in another video. As usual, thanks for watching.